All right, hey guys. So I'm going to try something new. I've never made videos before while I'm teaching or anything like that. So I don't really know what I'm doing, but we're going to figure it out and it's going to be great. All right, and the first thing we're going to talk about this week is relative age dating. Okay, and when we're talking about this, we're talking all about rocks. All right, so we left off last week talking about fossils and how geologists use fossils to see how organisms have changed over time. And they can also use those fossils to figure out how old they are. And some of the same geologists, they'll use all of these relative age dating laws that we're about to talk about to figure out how old certain rocks are, or which rocks are older than other rocks. So just to be real simple with it, relative age dating is how scientists figure out which layer of rock is older than the other. So when we talk about relative age, we are not talking about exact age, okay? I'm not telling you that a rock is 10 million years old. When we're talking about relative age, we're talking about this layer of rock is older than this layer of rock. So it'd kind of be like if you were in Walmart and you saw, a toddler and then you saw an adult. You might not know the exact age of those people, but you know that the adult is older than the toddler. And that's kind of what we're doing here, except for we're talking about rocks. Is you're not going to be able to tell the exact age of that rock, but you're going to be able to figure out, hey, this rock is older than that rock. And there's going to be 5 different principles or 5 different laws that we use to figure that out. So I'm going to switch over to my PowerPoint. All right, and mine might look just a little bit different than y'all's because I'm using keypad, and the one that I put on Canvas is Google Slides, but it's got all the same information, all the same content, okay? So, and remember, you are writing these notes in your notebook, and I'll do a notebook check when we get back for a grade. I promise you're going to get a grade for this. So that's part of your assignment today is these slides that we go over. Go ahead and write them in your notebook, all right? So this PowerPoint is going to tell us what does relative age mean, and that's kind of what we're talking about right now. So if I have layers of rock, and you'll see some real pictures in a minute that I think will make it a little bit easier, I need to know A or B, which rock layer is going to be older, rock layer A or rock layer B, and we're going to figure out how we can learn that. So that is what relative age means. And then we're also going to talk about how can the position of rock layers be used to determine the relative age of rocks. So that's what we're doing today. All right, so the very first thing is that geologists, remember geologists are our scientists that study the earth. They can study fossils, rock formations, earthquakes, volcanoes, all types of stuff. But they can use relative age dating to compare the age of rocks in an area, okay? And all that relative age dating is the age of rocks and other geological features compared with other rocks and features nearby, okay? We can't use relative age dating to figure out the age of rocks in Nevada versus Massachusetts, okay? They've got to be nearby in the same area, like on top of each other, okay? So everything here is going to be relative. All we're doing is comparing. Okay, so I told you there was going to be 5 different laws, 5 different principles. This first one is probably the most useful and definitely the easiest, okay? So when we see all these different rock layers, they kind of look like stacks of rock in different layers, okay? And remember, when we're talking about things that happen in geology, we're talking about things that take millions and millions and millions of years to form. So it's not like something that happens really quickly overnight. These are occurrences that happen over tons and tons of time. But over time, you'll have a layer of soil and dirt and rock, and more dirt and rock will get put on top, and more dirt and rock will get put on top through erosion and water carrying mud in and things like that. And as you do that, the oldest rock ends up at the bottom, okay? The oldest layer is going to end up at the bottom. And then new rock is going to get added on top of that, and on top of that, and on top of that. And then finally, at the very top of whatever the rock formation, that's going to be the youngest rock there. So if I label these A, B, C, D, and E, A would be my oldest layer, and E would be my youngest layer, due to the law of superposition, okay? This is just telling us that the older rock is on the bottom, okay? And that is the law or the principle of superposition. So superposition tells us in undisturbed rock layers, the oldest rocks are at the bottom of the layers. The deeper you go, the older the rock gets, okay? That's probably the easiest one to understand. It's the one that most years kids get correct the most, all right? The law of superposition. You're going to have to understand how to use these rules and then actually what the definition is, okay? So the first one is superposition. The second one, it's got a weird name, all right? Original horizontality, all right? It's talking about something being horizontal. So we've got words like horizontal and vertical. So this is original horizontality. And this tells us that most rock layers are deposited. That just means that they're laid down in horizontal layers. So I'm talking about picture A right here. So we have picture A and we have picture B. They're not the same place, obviously, but what it means about the rocks being laid down horizontally, or original horizontality, is that originally most rocks are laid in these flat lines, like what you see there in that picture. Okay, so they're laid in flat lines. So if you're a geologist and you come across a rock formation and all of a sudden they're not in flat lines, and B, they're not in flat lines, they're shaped like a W. All these lines are shaped like a W. Well, as a geologist, when I see that, I can say, well, hey, something happened, either an earthquake or something like that, it happened and took this rock that was originally flat, okay, because the law of original horizontality, originally this rock was flat, and then there was some type of geological event that came through and added all these jagged lines, okay? And there's a word for those jagged lines we use. Those are called folds. I think I should have some pictures of these open. So geological folds, we see here. There's a guy standing right there. These form after the rock is deposited in layers. All right, so the rock is originally flat, and then there's some type of deformation, something like it could be tectonic plates colliding, it could be earthquakes. They are going to cause the geological folds. So these other deformations that could occur, so you have folds, you could have a fault, or you could have an intrusion. So if we look real quick at some more pictures of those different examples. Faults are where you have there are 3 different types of faults, and we're actually going to talk about all of those in a couple of weeks. But the land is originally put in layers, in flat layers, and then there's a shift in a fault line, and that kind of messes everything up. So the reason, or the way that can be used as far as relative aging, is I know that first all these rows were in flat layers, and then whatever happened to create these folds, it happened afterwards. So when we're talking about relative aging, when I'm trying to describe what happens, I can say, well, hey, originally they were laid up horizontally, original horizontality, and then there was something that happened that created those folds. So that's number 2. Number 3 is lateral continuity, okay? Lateral continuity. When you're trying to work out problems and you're trying to look at layers and figure out which one is oldest, this is probably the one maybe that we use the least, but it's still one that you have to know. And so lateral continuity just means to continue, all right, is that the layers are deposited in these continuous sheets in all directions until they hit a barrier or something. So here in picture A, so we can label and talk about it, we can see that originally this layer would have gone through, even though there's this big hole, all right, that everything on this side of the canyon is the same as what's on this side of the canyon. And pretty much what that tells us is maybe there was a river that came through and washed all this space away, similar to what we see in the Grand Canyon. So what it tells us is even if a river cuts through the layers, all the layers on either side should be the same. So if I'm aging this rock, if I'm trying to find the relative age, I know that this layer is going to be the same age as this layer because it's just continuing even though there's some type of barrier there. All right. The 4th law is the law of inclusion. Okay. It is the law of inclusion. So y'all know that the word inclusion just in general means to include. And so with the inclusion, we know that when rocks form, they can contain pieces of other rocks. The rock containing the piece of rock must be younger than the older piece of rock. So that kind of seems confusing, all right, but it gets a lot easier if you look at pictures. So we're going to say that this is rock A. Pick a different color because it doesn't seem to show up as well. This is rock A, and we'll say that this is rock B, okay? Rock B is inside of rock A. Rock B in that picture is inside of rock A. For rock B to be inside of rock A, that means it had to have existed before rock A formed. So if rock B existed before rock A formed, then B has to be older. So if I'm asking you which one of these are older, A or B, you're going to tell me B because it had to have existed before rock A ever formed. So rock B is going to be my older rock and rock A would be younger. So over here on the other side, this is a different picture. Let's say that this is rock C and rock D. At this point, if I ask you which one would be older, what would it be? And it's going to be that rock D is going to be older because it is inside of rock C. If it is inside of rock C, it had to have existed before rock C formed. Okay, so it tells you that the rock containing the piece of rock must be younger. So this is the rock. A is the rock containing the piece of rock. So the one inside has to be older. The last one is the one that we'll talk about the most when we're doing our practices, is cross-cutting relationships. Cross-cutting relationships. So this is kind of showing you a sequence of how some things can happen. So down here in the bottom, we've got number 1, number 2, and number 3. And they're essentially trying to show you the exact same layers of rock over time as things occur. Okay? So cross-cutting relationship tells you that either an igneous rock, fault, or any other geological feature must be younger than any rock it cuts through. So rocks aren't always in these nice flat straight lines, okay? Like what you see, we'll say that this is picture 1, picture 2, picture 3. So in picture 1, we have these nice straight horizontal lines that are nice and easy to figure out. And if I labeled layers, let's say that this is A, and this is B, and this is C, y'all would tell me that A is the oldest and that C is the youngest because C is at the top, okay? And that's easy and that's simple. But then we have some stuff going on between picture 1, by the time I go from 1 to 2. And now remember, there is a ton of time that has passed between picture 1 and picture 2. But what has happened is a couple of different things, all right? So these rocks are in these flat, continuous rows. And then you have some type of intrusion, all right? So we've got magma that's going to intrude up or flow up, and it's going to go through the layers, okay? It's coming from, you know, the mantle of the earth, so it's going to go up through the layers. And in order for that to happen, because of the law of cross-cutting relationships, I know that this structure right here has to be younger than all these rock layers right here. So these rock layers had to exist before you had this magma flow up through it. Okay, so if I asked you what was older, A, B, or C, okay, you could tell me that A is the oldest because it's towards the bottom, and A is below B, but the youngest thing in this picture is going to be that geological dike that is going through those layers, okay? And the other thing, if you remember Law 4 that we just talked about, inclusions, I could also say, I could label this as, we'll say that this is D, this inclusion is D, and I could ask you what is older, C or D. And D is going to be older because it is an inclusion inside of rock C. So it had to exist before C could form. So if this is picture 1, this is picture 2, and this is picture 3. The only difference between picture 2 and picture 3, so you had the same thing going on, you had this intrusion, but then there was some type of earthquake, and it created a fault, and it cut that in half, okay? So as far as relative aging goes, if I say that this is A, this is B, this is C, and then this fault right here is D, all right, I know that D is the youngest thing on this picture, okay, because it literally cut through C. If it cut through C, it had to be younger. It had to be younger. And I think that's where I'm going to stop the video today. There are going to be a couple other YouTube videos that are not me, that are other people, that go through these laws and then go through actually working on a problem about how to tell the age of rocks. So today I want you to copy these notes. I want you to think about all these laws and how we're going to use them to figure out what rocks are older than other rocks. All right? Send me an email if you have any questions. Do all your work. See you later.